Well, hello there. Let's take a look at a question, which is, how am I supposed to know what the pressure of a gas is? Now, certainly we have pressure sensors and things like that, but there's a couple different ways of knowing what the pressure of a gas is. One is by comparing it to atmospheric pressure. And so we use things like a barometer and things like that, or we could use something called a eudiometer, something that looks roughly like this. Okay, so I have a gas that's trapped inside of this bulb, and we have it's plugged into one side of something called a U-tube. This is the original U-tube, where we have basically a glass test tube that has two openings. Okay, I just put a regular fluid in there and colored it, but usually it'd be something like mercury or ethyl alcohol or something that doesn't freeze, and we would be able to just see the difference of pressure systems. So on the outside of this tube, this is open to the atmosphere. And I can just look up what the atmospheric pressure is under certain conditions, or just get a sensor and so on. But the pressure on the inside of the of this eudiometer is the question. What's the pressure of this? I would certainly know the temperature because it's going to be the temperature of the room. I could actually figure out the volume of the gas because I measure how much I put in there, or apply the math to figure out the volume of this container. But the big question is, what's the pressure like? Well, what do you think? Look at this. If I know that the atmospheric pressure is by looking it up, and let's say that that pressure right now is like, I don't know, 785 millimeters of mercury. Okay, I just looked that up. Well, I could say from this scenario, since the water level on the inside of the tube is higher than the outside, what does that mean for the gas? It means that the gas would be weaker. Okay? Well, what does that mean if the gas is weaker? If I were to look real closely, and if this is a true eudiometer, I would actually see little graduations on here. I would be actually able to see little measurements, and we would say maybe this is 15 millimeters different. 15 millimeters higher on the inside of the tube versus the outside. And that's what the problems are going to look like. They're going to be saying what the state of this is. If it's 15 millimeters higher on the inside when compared to the outside, that means that the gas is 15 millimeters weaker than the outside. And so I would subtract. So the pressure of the gas would then be 770 millimeters of mercury. And by the way, in case you're curious, or because we have some other problems coming up, if we needed to convert that, because remember, this is just a tool for figuring out the pressure of the gas. If I needed to convert that into kilopascals for ideal gas law or whatever, remember the STP values. Standard temperature and pressure is always important with gas laws to know, but if I was going to go from millimeters of mercury into kilopascals, remember standard pressure is 101.3 kilopascals. Well, standard pressure in millimeters of mercury is 760. Okay, you just need to know that. And there's your conversion. Don't worry about any simplified versions. Just know this two values, pressure values for STP, and you'll be able to convert if you should find that you need it. Now there's another scenario that can come up when we're trying to figure out and determine what the value of the pressure of the gas would be. And that would be if it looks like this. Remember, this is your gas and this is your atmosphere. Pushing down on this side, the gas is pushing on this side. Well, the other scenario is that it's actually lower on the inside. How could I achieve that here? Well, how I would achieve that is by adding pressure, right? This would then reflect the picture in that the pressure of the gas is actually stronger than the atmosphere. If I find that it's lower on the inside, that means that the gas is stronger. And again, if this was 785 millimeters of mercury, and say now this time, let's say that there's a 10 millimeter difference. It means that the gas is 10 millimeters stronger. And so what's the pressure of the gas? 795 millimeters of mercury. Now, I get a lot of people that actually lose their way in all of these numbers and conversions and everything else. And they think that this is a P1, P2 value and so on. Be careful. I'm not doing combined gas law with this. I'm not changing the conditions of the gas at all. I am simply just figuring out what is the pressure of the gas in these conditions, okay? And so this is actually, if I'm using a combined gas law, this would be my P1, and then the following question would be, what would it be, what would the new pressure be if I did this? Or if I increase the pressure or decrease the pressure, what would happen? Be careful, don't fall down that trap, because we're just using a eudiometer, a gas collection device, to figure out what the pressure of the gas is when you compare it to the atmospheric side. Okay, so that's how you use a eudiometer. I also went through a little bit of converting millimeters of mercury into kilopascals should you need. But from there, use your diagram and determine, is the gas weaker or is the gas stronger than the atmosphere? If it's weaker, you subtract. If it's stronger, then you add. That should be good enough for figuring out the pressure of a gas using a eudiometer.